Demultiplexer. A demultiplexer is usually a circuit which receives information on a single line. Let us take this data input be the single line, and this single line information can be given to output. These are all the following outputs. This can be also be called as a data distributor, since the input we can receive by this only one input, isn't it? This one input can be distributed through to all these outputs with the help of the selection line. So that's why your demux can also be called as a data distributor. See here, your data input, that is the available input, can be given to this output y0 with respect to the selection line. Suppose if I need to give the data input to y1, then that will be only decided with the help of the selection line only. That's why your input will have only one line and your output will contain 2 power n output lines, where n represents your number of selection lines. Let us take suppose if it is a 1:4 demux. What is your 4? Your 4 is nothing but your output, 1 is nothing but your data input. How you can get your 4? 2 power 2 is 4, isn't it? So that 2 power 2, n represents 2, that 2 becomes your selection line. Suppose if it is 1:8, then 8 becomes your output. How we can get 8? 2 power 3 is 8. Then 3 becomes your selection line. So let us see the types of demux. Let us see. First is 1:4 demultiplexer. See here, only one input is there and 4 output is here. In order to get 4 output, 2 power 2 is 4. That is 2 power n outputs. Instead of n, we can substitute 2, because 2 power 2 is 4. That 2 is nothing but your selection line. Here the selection line we can term as S0 as well as S1. See, first if I need to route out or distribute this D in to Y0 in the sense, then I have to make the selection line S1 and S0 be 0 0. That's why here S0 bar, S1 bar, again the D. These three has to be given as input for this AND gate. Then what is the fourth input? This is nothing but enable. We can include enable or we can exclude enable. If enable is on, then entire circuit is on. Okay. Suppose if I need to route out the D into Y1, then what will be my selection line? First, for getting D in this Y0, we will be giving the selection line as 0 0. For getting the D1 in Y1, we will be giving this 0 1, isn't it? So 0 is nothing but S1 bar and 1 is S1, sorry, S0. Similarly, if you are going to have D in and if you are planning to route out D in towards Y2 in the sense, then my selection line should be 1 0. What is 1 here? S1 is 1 and S0 is 0. Similarly, your D in has to be given to all the AND gates. Finally, if I need to route out this D in towards the output of Y3, my selection line should be 1 1. That's where S1 is also 1 and S0 is also 1. So at a time, you can only get D in through any of these 4. These 4 will not give output simultaneously, but it can give output at a that is, the output can be visualized in any of these 4 gates. That thing will be decided with respect to your selection line. Let me clearly explain here. This is 1:8 demux. So 1 is your input, 8 is your output, 2 power 3 is 8. That's why we are getting 3 selection lines. That selection line may be S0, S1 and S2. See, if I need to get my D in and if it is routed out to Y0, that is, I am getting D1 in this place, Y0, isn't it? I am transferring the information from D in towards Y0. Then what will be my selection line? My selection line has to be 0 0 0, since it is 3 bits combination, isn't it? So what may be the possibility? 0 0 0, 0 0 1, 0 1 0. It will continue up to 111. See here, see the truth table here. So if my selection line is 0 0 0 and my D in is on, you will be getting the output Y0. That's why you will be having D in here. suppose if your selection line is 0 0 1, see here 0 0 1, then you will be getting the D in Y1. Similarly, if my selection line is 0 1 0, you will be getting the output in Y2. It's continuously going on. When your final selection line is 111, you will be getting your output in Y7. See here, at a time only one output can be on, remaining output will be off. So this will be controlled with respect to your selection lines only. So this is the block diagram as well as logical representation of your demux. So keep it in mind that always for demultiplexer there should be one input and 2 power n outputs there, where n represents your selection line. Also in that output case you will not get simultaneously all output on. At a time you can get output at one gates. That is, for example, here at a time you can get output in either Y0 or Y1 or Y2. This can be explicitly controlled with respect to your selection line. So next is, let us see the question here. Design 1:8 demux using two 1:4 demultiplexer. Now we are going to design your demux, but in question we have to design 1:8, but we should use 1:4. So how many 1:4 we can use? We can use two 1:4, isn't it? So this is your mux 1 and this is your mux 2. So commonly you will be having only one input, isn't it? So see here, this D in will be input for this mux and this D in is also input for this mux. But see here, what will be the output for first mux? It is Y0, Y1, Y2 and Y3. For second mux it is Y4, Y5, Y6 and Y7. So what is the case and what is the operation of your mux? At a time you can get output in only one place, isn't it? But now we are having two muxes. What will be the selection line for this mux? Since it is 1:4, 2 power 2 is 4, so 2 is your selection line. That selection line becomes S1 and S0. So how can you control these two muxes? With the help of selection line. But at a time only one demux can be operated at a time. This can be controlled with respect to enable. See here, this is A, this is given to both enable. From this point, if A is 0, next 0 will be applied here, your demux 2 will be in off position. This 0 will be given to NOT gate. After getting output you will be getting 1 here. See, the input is 0, what will be the output of the NOT gate? 1. So this 1 will be going into the enable. So this demux 1 will be now in on state. So based on the selection line you can get D in either in Y0 or Y1 or Y2 or Y3 with respect to the selection line. Suppose let us take the value as 1. If it is 1, the 1 is applied to demux 2. Automatically your demux 2 will be in activated state. What will be the output of this NOT gate? If the input is 1, the output is 0 here. This 0 will be going to the enable. So automatically your demux 1 will be in off state. So now you can get the outputs in Y4, Y5, Y6, Y7, but at a time you can get only output in one place. That is, you can get output in Y4 or Y5 or Y6 or Y7. That purely depends upon the activation of your selection lines, isn't it? So with this design of 1:8 using two 1:2 demux over. Now the next problem is 1:16 using 1:4. So how many 1:16 can be how many 1:4 can be used in order to get 1:16? You have to use 4 1:1 demux, isn't it? So see here, 1, 2, 3 as well as 4. So you will be getting 4 1:2 demux. Before getting into this, now initially I am using 1 1:4 demux. Automatically my input is 1, my output is 4, that is Y0, Y1, Y2, Y3. Now this Y0 will be input to the demux 2, Y1 will be input to the demux 3, Y2 will be input to the demux 4 and Y3 will be input to the demux 5. Suppose if I want to get D in with respect to this output Y0, that is I am routing out this D in towards Y0, then what will be my selection line? Both will be 0 0. At a time this output will be enabled and these 3 will be off. So this output will be input to this demux. Again, in order to get the output in any of these O0, O1, O2, O3, again I have to select the selection line S1 and S0. Similarly, for the rest of the operation will be continued in this pattern. If I am getting output here, automatically you will get outputs here also. If I am getting output in Y2, then this will be the input for demux 4. Again, I can get outputs in any of these O8 to O11. If I am going to get my output here, then my input should be get from this Y3, isn't it? At a time your selection line will be both will be 1 and 1, S3 will be 1, S2 will be 1. So if both becomes 1, you will be getting the D1 in Y3. Again, this output will be input for demux 5. Again, this D can be get in any of these outputs with respect to the selection lines. So with this, design of 1:16 using 1:4 demux completed. Thank you.